So I want to take a look at the solutions to a few of the problems that we were assigned last night. In one of the sections, we are asked to determine the number of possible solutions for each triangle. And I'm just going to take a look at number 13 here. And on number 13, we're given angle B is 61 degrees, side A is 12, and side B is 8. And remember, our strategy has been to convert these so that we can use our notes and our cases to decide how many solutions there's going to be. I've got a little small picture of our notes here on the left. And notice that letter D is our given angle, so that's going to be the 61 degrees. And then lowercase d is the side opposite of the given angle. So for us, that's going to be this 8 right here. And then the adjacent side, which I'm calling M, is 12 degrees. And then what I want to notice is that D is less than 90 and lowercase d is less than M, right? And I get that information just by looking at this given information. D is 61, which is less than 90, and 8 is less than 12. If that's the case, D is less than 90 and D is less than M, then I'm talking about case 1. And when we're doing case 1, you have to compute that height. So the height is M, which for us is 12, times the sine of D, which is 61 degrees. We're going to compute 12 times the sine of 61. And I'm typing it in right now. And I get 10.49, so approximately 10.5. That's our height. So now I'm going to look down these choices and see how D compares to that. We're comparing D to 10.5, 8 to 10.5. And in this case, D is less than 10.5, so we have no solutions. So the number of solutions is 0 for number 13. And that's the process that we run through. We label our 3 values, capital D angle, the angle, capital D, lowercase d, which is the opposite side, and M, which is the adjacent side, and then we use these cases that we've developed to decide how many solutions there's going to be. Let's take a look at number 17. So I'm going to focus on number 17. And again, I want to get organized. They're asking us how many possible values are there for angle B. All right. So first of all, let's figure out what we're dealing with here. I'm going to convert this over to our language just so it matches my notes. D is going to be the angle of 65 degrees. The opposite side is A, because if this is angle A, the opposite side is A. So my letter D is going to be 55 units. And then B, which is that adjacent side, is 57. Okay, now remember in that triangle what we're talking about then, if we draw this thing. This is angle D down here. This is side D over here, and this is side M. We're actually curious about angle M here, right? The side that's opposite the 57. And basically there's going to be either 1, 0, 1, or 2, right? Because the other angle M could be right here if D is of a certain length. So we'll go through our cases, and the same situation with the number of solutions is how many values there are for B. So letter D is less than 90, and D is less than M. Sorry, that's the wrong D. Lowercase d is less than M. So again, that is case 1. And I have to compute the height. So that's going to be M, which is 12. Excuse me, M is not 12. That was the last problem. M is 57, and then the angle is 65. So I'm going to compute 57 times the sine of 65 degrees. And that is 51.6. Okay, letter D is bigger than 51.6. So D is greater than the height. And that is this choice right here. So that means we're going to have two solutions. If we're going to have two solutions, it means we have two values for m. So my answer on this problem is going to be 2. If there are two solutions, there's going to be two values for letter m. And that's how you do number 17. Let's take a look at a few more problems from this lesson. In this section of the assignment, we are asked to find all the solutions for each triangle. There might be no solutions, and if that's the case, you're going to put none. If there's one solution, you'll find the missing pieces, and if there's two solutions, you'll have to find the missing pieces for both of the triangles. What I want to do in this particular slide is take a look at number 23. And you know the process by now. I'm going to convert this over to this is number 23. I'm going to convert this over to my notes, where I use letter D is my angle, so 90 is my angle. Side B is associated with angle B, and so that's my letter D. And then side A is that adjacent side, my letter M. Okay, now I notice that D equals 90. So that means either case 3 or case 4, right? D is greater than or equal to 90. And then what I have to do is examine D's relationship to M. D is less than M because 12 is less than 14. And so right here, that is case 3. And case 3 is no solution. So I'm going to put none. So for this problem, I examine the information. I find out it's case 3, and that one is none. I like that problem. Didn't have to do a lot of math. Let's take a look at another one. On this side, let's take a look at number 25. I'm going to get organized. My angle is 107.2. My opposite side is, let's make sure I got these matched up right, 17.2. And my adjacent side is 12.2. And we need to determine how many triangles there are so I can decide if I can find the solutions or not. So I notice that D is greater than 90, and I notice that little d, lowercase d, is greater than m. So D is greater than 90, and D is greater than m. That's down here on case 4, so I have one solution. Okay, so I'm going to have to do the problem. I'm trying to write one solution here. That means I have to find the missing side and the two missing angles. So for that, we'll just use the law of sines. So I'm going to try first to find the angle opposite my letter M, which in this problem is capital C. So I'm going to find angle M, capital M, using the law of sines. And my letter D is 107, and side D is 17.2. So to solve for this angle, I'll multiply both sides by 12.2, and then I'll do the inverse sine. And so angle M will end up being the answer to this calculation. Let me crank this out of my calculator. So when you compute 12.2 times the sine of 107.2 divided by 17.2, you get 0.6776. And when you compute the inverse sine of that, that comes out to approximately 42.7 degrees. So this missing angle, which for them is angle C, right, is 42.7 degrees. That means we can quickly get the third angle. Since we've given angle A and angle C, we're going to call that angle B. So angle B is going to be 180 minus 107.2 minus 42.7, and that's 30.1 degrees. So I did 180 minus 107.2 minus the new angle 42.7, and that's going to be 30.1 degrees. So I've got the angle. I'm missing a side here. So we're going to have to do law of sines to get that last side. So the last side would be the side that's associated with this angle B here. We don't have that one. So side B over the sine of B, which is 30.1, will equal, pick a side here, 17.2 over the sine of 107.2. Those match up, letter D's. And to solve this, I need to multiply both sides by the sine of 30.1. And I'm going to squeeze it in on this slide, even though it doesn't make for a very good presentation here. Side B will be this calculation. This should be 30.1, not 31. So when you do this calculation, 17.2 divided by sine of 107.2 times sine of 30.1, that comes out to be right around 9.0 for the measurement. Okay, so just to be clear, we know we have one solution because we did the test and we found that it was case 4, right? We solved for angle M first, and that was 47.2 degrees. We used subtraction to get the other missing angle, which is 30.1, and then we used the law of sine to get the missing side. So I have 3 angles. I have 107.2, 47.2, and 30.1. And I have 3 sides, 17.2, 12.2, and 9.0. Those are the measurements for this triangle. Let's take a look at number 30. So in number 30, we're basically being asked to do the same thing. Notice I'm going to label this angle letter D, capital D. That means this side is the opposite side, which is letter D, lowercase d. This is my M, which is the adjacent side. And so what we're going to have to find in this triangle is angle M, and then I'm going to call this angle C and side C. That's what we're looking for. It says copy the triangle and label all the measurements. So let's do this. Okay, this is number 30. D is 57.4. Lowercase d is 21.7. And M is 19.3. Now let's bring in our notes so we can figure out how many solutions there's going to be. And I'll put that right here. D is less than 90, so it's acute, right? I know that. And lowercase d is greater than M. All right, so that looks like it is case 2. There's one solution, so we just need to find out what the other parts are. Okay, I'm going to dive in with the law of sine here, and the first thing I'm going to get is angle M. If I get angle M, I can use subtraction to get angle C. So for angle M, I'm going to do the sine of M, which I don't know, over the measurement 19.3 equals the sine of 57 over 21.7. And you know how I'm going to solve this, just like I have all the other ones. I'm going to multiply both sides by 19.3. This cancels out. And then I'm going to do the inverse sine. So M is going to be the inverse sine of that calculation. And when I do the calculation, I get 0.7777. That's a weird number. And the inverse sine on that value is 51.1 degrees. So that's my second angle. This guy is 51.1. Okay, let's get the next angle. So that would be angle C up there. The measure of angle C is going to be 180 minus 51.1 minus the 57.4. And that equals 71.5 degrees. So that's this guy. And now I have to do the law of sine to get letter C here. So let's go with C over the sine of 71.5, since that's the angle that's opposite it. And we'll just use letter D again. So 21.7 over sine of 57.4. I started with the sine measurements in the denominator because it just makes one less step I have to go through to solve. I'm going to multiply both sides by the sine of 71.5. This cancels out. And now when I do this calculation, I'll have side C. So typing this into the calculator, I get C to be approximately 24.4 centimeters. And so that will be labeled right here, 24.4 cm. So I found all the missing measurements and I labeled them. Let's just make sure everything looks right here. This side is already 19.3, this side's already 21.7 centimeters, and this is already 57.4 degrees. We used the law of sine to find this angle, which was 51.1. We used subtraction from 180 to get 71.5 for this angle. And then we went back to the law of sines to get the 24.4 centimeters. And we did it. We got number 30 done here. One more problem, and then we'll wrap this video up. In number 31, you're asked to find the perimeter of each of two non-congruent triangles. And then we're given these measurements. So essentially what they're hinting at is that there are going to be two solutions to this problem, so you have to do the problem twice. Okay, and then to find the perimeter, you have to add up all the sides. So that's the final step in this problem. So for number 31, let's start with what are we given? We're given our angle, which is 29 degrees, so that's less than 90. We are not, yes we are, here it is. Side A is opposite the 29, and so that's going to be letter D for us is 15, and then letter M is 20. And let's bring our notes in so we can figure out what case this is. So when D is less than 90, and this is 20, and D is less than M, that's case 1, and we have to compute right, that's case 1, so we have to compute the distance, the height. The height's going to be 20 times the sine of 29, and that equals 9.6. So our D is greater than 9.6, and that means we are case 1C, which is what we figured because they said there were two triangles. So this is the ambiguous case. We got to find both these things. Okay, let's get the first triangle, and that'll be when we solve for angle M. So the sine of angle M, oops, I wrote sim again. That happens from time to time. Over 20, side M, and then the sine of 29 over side D, which is 15. Multiply both sides by 20, and we'll get the sine, and then we'll do the inverse sine. So I multiply both sides by 20, and then I'm going to do the inverse sine on this calculation. Oops, that's the highlighter, not the pen. So the angle is going to be the inverse sine of, and the calculation gives me 0.6464. And the inverse sine of that is about 40.3 degrees. To get the other angle, I need the other angle to get the side, even though it's not specifically asked for it when we need the perimeter. But I do need the other angle so I can get the missing side. So the other angle is 180 minus 40.3 minus 29, and that is 110.7. And then we need to find the third side, and so we'll use the law of sine again. I'll put letter C here over the sine of 110.7. And that's going to equal, let's just use D again, that's 15 over the sine of 29. I'll multiply both sides by the sine of 110.7. These cancel, and I'm going to find out that C equals the answer to this calculation, which is 28.94. We'll call that 28.9. And then the perimeter, P, is going to be the sum of the three sides. So 15 plus 20 plus 28.9. and that's going to equal 63.9. So that's the perimeter for, oops, that's not the highlighter. Let's try this again. 63.9 is the perimeter for one of the triangles. We have to do this all over again, although it's going to be much faster, to get the perimeter for the second triangle. So I've run out of space here. We'll get that on this next slide. So we're working on number 31. We've already found the perimeter of one of these two non-congruent triangles. We're trying to find the perimeter of the other one. And we can use some of the work that we had on the last slide to make this go a little faster. Here's our given information. We have one angle and two sides. And we found in the last slide that the measure of angle M was 40.3. But because this is an ambiguous case, we also know that there's another angle M, which is 180 minus 40.3. And that equals 139.7 degrees. And so this will be the angle that we use to get the new angle C. So this guy's an angle, this guy's an angle. The new angle C, which is going to be 180 minus 139.7 minus 29. And so the new angle C is 11.3 degrees. And now all I have to do is find that missing side so we can add up these three new sides. So my side C is going to be across from the 11.3, so over sine 11.3 degrees. I'll stick with D again, and I'll put side D, 15, over the sine of angle D, which is 29 degrees. You know how I'm going to solve this. Multiply by the sine of, 11.3 on both sides. This one cancels. And I'll get side C by doing this calculation. 15 divided by sine of 29 times sine of 11.3, which comes out to about 6.1. So I have my three sides, and that's going to help me get the perimeter. The perimeter P is going to be 15 plus 20 plus 6.1, which equals right around 41.1 units. And that's the second perimeter. So we had, 63.9 and 41.1. So right around 64 and 41 for the two measurements. So that's number 31. Long problem, especially when you got to talk your way through it. But that's the idea behind this ambiguous case of the law of sines. Okay, hopefully this helped you get a handle on the homework problems. Feel free to cheat off this, and then, we'll continue to work on these. But for now, just take care, and I'll talk to you soon.